Okay, let's give you guys some more practice. So find the Maclaurin series for this function up to order 4. So press pause and have a go. Okay, so if you try to use this series, it becomes very complicated because your series, each of the power of the bubble, your series will give you this. But then here you've got e to the power of x. So you've got to put e to the power of x in here. So e to the power of x in here, e to the power of x in here, e to the power of x in here. But this e to the power of x, this is the series itself. So you've got to put this into here, and then into here, and then it becomes very, very complicated. A better alternative is to do it like this. So you start out with your function, and then differentiate it. That will then give you this, and then here you've got one block multiplying another block. So you've got to use a product rule. So if you differentiate this, so the product rule, blah blah blah, differentiate it, it will then give you this, and then differentiate it again. That will then give you this. If you differentiate it again, so here you've got one block multiplying another block, so you've got to use the product rule. So differentiate this, so that will be this times by the bubble itself, which should be this, and then leave this alone. So you leave this alone, and then you plus, and then now you leave this alone, and then differentiate this. So you leave this alone, differentiate this, that will then give you this, and then it's blah blah blah, tidy up. It will then give you this. So now you've got one block multiplying another block. So if you want to differentiate it again, then you've got to use the product rule. So the product rule is differentiate this, so that would be this, and then leave this whole thing alone, and then plus, and then leave this alone, and then differentiate this. So that will then give you this, and then if you tidy it up, it will then give you this. Okay, so the fourth derivative is this thing here. So let's go back to here. So really, hang on. So f of 0 equals e because hang on, going back to here, we need to evaluate f of 0. So we've got to put 0 into this x. So we've got to put 0 into this x. So e to the power of 0 will be 1. So this thing here becomes 1, and then e to the power of 1 is e. So now we know that f of 0 equals e. Now let's look at f prime. So we've got to put 0 into here, because remember Maclaurin series, we always evaluate it at 0. So put 0 into here. That would mean you putting 0 into here. So this thing here will become 1. So e to the power of 1 is e, and then we've got to put 0 into here. So that will be 0, e to the power of 0, which will be 1. So it would be 1. So f prime of 0 evaluated at 0 is e, and so on. So if you look at, I don't know, this one here. Now let's look at put 0 into here. So that would mean you putting 0 into here. So this will become 1. So this bit here will become e, and then you've got bracket, and then you've got to put 0 into here. So that will be 1, and then hang on, let me think. 0, 1, yeah. And then you put 0 into here. So this will be 1. So plus 1. So that will be 2e, and so on. So hang on. So f double prime evaluated at 0 is 2e. The third derivative evaluated at 0 will give you this. Fourth derivative evaluated at 0 will then give you this. So now remember the Maclaurin series. So hang on. So the first term would be n equals 0. So we've got to put 0 into here. So x to the power of 0 will be 1. So this thing here will be 1. So we've got to put this into here. So that will be e. Well, the first term will then give you this. Now n equals 1. We've got to put it into here. So this will be x, and then 1. So that's the first derivative. So we've got to put this into here, and then 1 into here. So that will then, so when you put this into here, this thing here will be e over 1, and then this will become x here. So that will then give you this. And then the third term, we've got to put it into here. Hang on, third a second. Well, blah blah blah. We've done this many times, so after all that, it will then give you this. So this is your final answer. Okay.